Okay, I'm going through the main problems with your assignment on the effect of forces, right? This assignment 1. Okay, firstly, the 3 forces. Okay, A has been drawn for you, right? So that's actually the hard part, right? So for weight of the box, you cannot anyhow place, because now you have learned what center of gravity is. There is an expectation that you should have the capacity to find the center of gravity of the box, alright? Which requires you to plot this dotted line, alright? There is the diagonal for the box, and the intersection is where the center of gravity is, because we assume it's a uniform box, alright? And that's where your weight should start from. Okay, so now because you have learned the concept of center of gravity, there are points where you may need to find the center of gravity before you draw your weight from that position. Okay, for the force between the ground and the wheels, right, this is actually a normal contact force. Some of you interpreted it as a frictional force. Right, in this context, if it were a frictional force, alright, you have actually some form of net force, right, which is unlikely in the context of a question like that. Okay, so just take note that in general, when in doubt, okay, you can just assume that the object is in equilibrium. Alright, so some of you thought the frictional force looked like that. Alright, instead of drawing the outward force, okay, which is confirmed wrong, because you can see this outward force here is actually very important. Outward force is actually very important, because without this force, right, can you see your A is downwards and your W is downwards? Okay, then you definitely have a net force downwards. Alright, if your only forces were A, W and F, right, you definitely have some form of net force down and a net force to the right. Okay, so therefore actually F, right, being here, right, so this is the wrong F by the way, F being here is actually very important. Right, state principle of moment, I'm not going to say too much. I said some of you don't even bother to read your textbook. Right, things like when a body is equilibrium is not written, the sum of clockwise moment, the word sum is important, right, and the word pivot is important. Right, actually this should be pivot, right? So I think this word here, I think preferentially should be changed to pivot. Okay, so moving on, how the design of the trolley makes it easier to lift the load. Remember that when you answer physics questions, you cannot answer in words that you learn from other systems. Right, you must know what a moment is. It's force times perpendicular distance. Right, therefore the word perpendicular distance is very important. A lot of you just tell me the distance between the handle and the pivot is very long. That is not accurate enough. Alright, you have to tell me that is the perpendicular distance between the handle and the pivot that is very long. Alright, so that is a key part of answering the question, stating the word perpendicular, right? And because this line is very long, therefore the force needed can be much smaller than the weight, right? Because the weight has a short perpendicular distance, the moment it creates is small, right? So you can have a smaller force, applied force, for you to go against the weight's moment, right? Okay, moving on. Right, this question, right, calculate the distance y. Alright, this one is not too badly done, right? So I think no issue here. Okay, as long as you substitute correctly, again, I will remind you that this should be mass times small g. Alright, so mass convert to kg, small g convert to gram. A lot of you like to shortcut. If you shortcut and get correct, nobody cares, you get full mark. If you shortcut and get wrong, don't ask for PT marks, not going to happen. You just give you a straight 0. Okay, so it's mass times small g, that will give you weight of, in this case, P, right, multiplied by y, which is the perpendicular distance, and the other side will be weight of Q times perpendicular distance of Q. You realize that I left this in cm, which is a bit unusual, except for the fact that I actually expect y to come out in cm. That's why I didn't bother to change this to meters, but some of you change to meters, it's perfectly fine and acceptable. Right, so some of you gave me in meters at 0.077 meters, which is perfectly fine. Right, we look at the weight of R and S. Alright, so how to find the weight of R and S? We need to first understand that it looks complex, but actually when we look at moments questions, generally we are looking at just beams, right? So if I take this as rod 1, right, how many forces act on rod 1, right? I'm talking about rod 1, this one. Alright, so there's an outward force here, that is the string, right, from the string here. Okay, there are 2 downward force here, right, because it's being pulled down by this thing, this whole system. I can see this whole thing as one thing, and I can see this whole thing as one thing. Alright, I'll call this A and I'll call this B. Right, so it's pulled down by A and this pulled down by B. What is the force exerted by A on this rope here? Right, the force exerted by A is actually the sum of all the mass in this area. Right, so if I assume the rod is light or massless in this context, then the total mass of this system A is actually 250 grams. Right, so it's actually 250 grams. Right, then I want to change to kg, right, times that. So this is the mass. This is the weight of A, right? And then the weight of B is actually same idea, right? I know these two things, R and S, right? This is the mass of R and the mass of S, right? Multiply by 10, right? And this one represents the mass of everything at B. Okay, so if I'm looking at this thing and I take pivot at the center, why? Because that gets rid of the tensional force upstairs, right? I know this is Z. Right, then I can take moments about this position, okay, and have this value, which is the weight due to A, multiplied by perpendicular distance, must be equal to this value multiplied by perpendicular distance. Alright, okay, so something to that degree. Okay, I'll just write it out for you, times Z. This will be equal to times Z. So you can see clearly Z cancels out, the 10 cancels out, and it's just 250 over 1000, which is 0.25 equal to R plus S. Alright, and R and S, because if you look at this system, they are the same distance away, then they must have the same mass, right? So actually I can call this 2R. Okay, 0.25. So R is actually 0.125 kg. Alright, but what am I asking for? I'm asking for the weight. So sadly, a lot of you left R in grams, which is terrible because you don't realize that grams is a unit for mass, right? So if I want to convert R to weight, I need to times 10, right? So 0.125 times 10 is 1.25 newtons, right? Weight is always in newtons. Okay, so since we already concluded S is the same weight as R, right? If Q falls off using moments, state and explain what happens to rod 1 and rod 2. If you use moments, alright, the conclusion must be it stays in equilibrium. That means it doesn't rotate, or it rotates clockwise, or it rotates anti-clockwise, right? So the statement of what happens has to be either clockwise or anti-clockwise. If I see any other answer like, oh, tilt down, tilt to the direction of P, or tilt to the direction of RS, all these I'll give 0, because it's not a proper way to describe the effect of a moment. Alright, so it rotates clockwise, rod 1, because the weights R and S are now the moment due to R and S. Right, do not compare the forces. Right, remember that in this case we are talking about moments. Alright, there is a greater moment from R and S than there is a moment from P. Right, because initially P had the support of Q. Right, so now with Q gone, R and S clearly gives a bigger moment than the moment due to P only, and therefore the clockwise aspect wins. Okay, likewise in the other case, when I talk about rod 2, since only P is left, there is only an anti-clockwise moment. Right, there isn't even a clockwise moment in this case because Q has disappeared. Alright, so that's how to answer the questions.